Welcome everyone. This is the first of our virtual knowledge sharing sessions or Adeva Insights. Today we'll be discussing a bit different concept of software development, which I like to call time-driven development. And this is the difference from all of the other best practices for software development, is that the sole focus is on the development time. And this is not something like building things without thinking about, how it's structured in the background, or if it's going to break afterwards, just to make it, to ship it fast. It's more of trying to find the best approach of building something where you choose the right architecture or the right software design based on the current needs of the project. And at the end, the result should be optimized development time or saving time on the long run for the whole team. To explain it a bit better, I'd like to go through some quotes and tweets that outraged the internet at some point. So this was a very popular one from a couple of years ago. Johannes Bradwell over here had this outburst towards Uncle Bob and clean code, everything that it represented. Because at one point he realized that he always stayed 2 hours later than his coworkers in the office, trying to polish and clean up a piece of code that was already clean enough, just so he could adhere to the clean code practices and be accepted and be praised by his team and other fellow developers. And this is a trap that we often get into, because trying to follow all these best practices, we are essentially focused on the practice as a result. So how clean is my code? Or in the next example, we have this over fragmentation just for the sake of the single responsibility principle. So the Stack Overflow user over here is actually asking how to refactor away from single responsibility principle. And when you see this, it's a red flag, because single responsibility principle is one of the solid design principles, has for a goal to help developers organize their code better, to have separate functionality, separate responsibilities in separate places of the code, so that you can easily find what you're looking for and make your code easy to read, to maintain, and to extend on the long run. But when you have a code so fragmented that you're unable to read it, you're unable to find what you're looking for, and unable to maintain it as a result, then you realize that you're doing something wrong, because single responsibility principle is not the goal as such. It's something that you should use to make your life as a developer easier. And if we dig back in the past, this is all motivated by Uncle Bob, the inventor of clean code and solid design principles himself. So this is a quote from The Obligation of the Programmer, one of the several rules that he had put in place. And he says, so he explains how developers should be proud of the work that they accomplished each day at work. And when he says proud, he focuses on software that's fully tested, or practicing TDD, or following solid design principles. But the bottom line is, when you go home and look in the mirror, you're proud of what you've accomplished that day. And thinking about this, it's kind of unnerving, because yes, we should be proud of what we've accomplished as developers, but not proud of what tools we've used to build our software. But instead proud of the value that we create for our users, the value that customers and people who are using the software that we built are getting on daily basis. And software cannot be fully tested ever, right? So focusing on all these best practices is actually making programmers' lives miserable instead of easier. And this all contributes to an environment that's very toxic for engineers, and values the usage of good design practices above creating value for the users. And I'm putting this good in quotes, because good is dependent on the context of the project. So what a good design means for one project, it doesn't have to be the same for another one. And on the other hand, a lot of you would probably roll your eyes on this. But this is a very popular example. It's also very old, from 2017. But it says that Remote OK, which is a very popular website for remote jobs, is a single PHP file, index PHP, where all of the software logic is dumped. But it generates over $2,000 in a day. And this is around 3 years ago. So right now it's probably generating more unless it's refactored. But in any case, this is another proof that we can go on the other side of the spectrum and not care about good practices or code maintainability or anything, as long as we're generating profit from our project. So these are the two differences of software approaches, and kind of finding the middle can be hard. So that's where time-driven development actually comes in. So the purpose of it is basically to help us understand when should we go on which side of the spectrum. So when should we focus on creating a better software architecture, following design practices, or writing solid code, and when should we go on the other side and make sure that we are just focusing on simplicity. To explain this in more details, I'd like to focus on some concrete examples. The first one is developing the profiles on our platform, which are the profiles of developers, designers, and back when we were starting, it was mostly for managing our applicants, the candidates who wanted to join our community. And this is how that profile looked like back then. So we had this opportunity here to edit the summary for the candidate, add some experiences, education, and everything, basically manage all of the candidate details, and access some stats and other management tabs over here. What we wanted to do at that point was not focus that much on developing the full functionality on our side, but take a more lean approach where we can reuse other tools and apps that we had at our disposal. So basically what we did is we used CRM, which we already had in place, Zoho CRM, where all of our candidates were added as they applied to join us, and then we just pulled their details on our side on the platform so that they could easily manage their profiles. And in the background, that looked like this. So just a disclosure at this point, I'm going to be using Laravel for all of the examples, but this is easily applicable to any other programming language or framework. So just use it as a pseudocode as you're reading through the examples. So basically the backend of this was this large class called Zoho Candidate, where we had all of the methods we needed for managing people in the CRM. And this was everything that we needed at that point. Opportunity to get the candidates, their experience, education, and all of the related data. So when we implemented this on our side in the platform, we basically instantiated this Zoho class and called the needed methods so that we can pass them to the view. This is that part. And this is the first red flag that is increased at this point because the controller now knows too much and is open for modification. Why? Because at a later point, if we want to replace this with a local database, and we did want to do that because the purpose of starting lean was to be able to gradually add all of these features to our local database so that we can remove the CRM overall. And this wasn't allowing us that because with this type of instantiation over here and calling these methods, this controller knows how to instantiate the class that we're going to use to get the details. It knows what methods it needs to call. And if we want to change the approach of handling the data in the background, we would need to come back to this method over here and change all of this because it won't work with a local database. The second part, which is another red flag here, is using this naming convention over here, which is very closely tied to the CRM. So we depend on their naming conventions, we depend on the storage that they have in place, And if we want to translate this to a local database afterwards, we would probably, so we would either need to use the same naming that they have, or rename everything and change everything in the code. So again, it's very volatile and not error prone, basically, with this approach. This is just to add to the same example, the blade view. So basically, this is the part that we need to focus on here. For every part of the view, for every piece of code where we need to access the background data, we are still using the same naming convention from the CRM. So basically, our views are also dependent on that same storage. And in the future, so this in Laravel, we would use objects afterwards, or collections, to access the data from the MySQL database. So basically, we would need to change all of the instances where we are accessing this data with arrays to objects. And if you do quick get diff here for the method that we were looking at and the blade view afterwards, you can see that over here, the red lines are basically the initial implementation of the function. And now when we are trying to replace it with a local database, we basically need to rewrite everything. So now we are using a user model that we have in place with our MySQL and Laravel setup. And then we are using eloquent relations that we have over here to access all of the related details. So this resulted in a full rewrite of this method. And the problem is not if there's only one method, but if we need to do the same with all of the functionality that we have on the platform, then it's a lot to handle. This is how the view looks like. So again, we need to replace all instances of the previous database access to the new one. So we're depending on completely different logic right now, and need to replace all of the old lines with new ones. So if we recap on what it takes to actually change the storage, we basically have a few points that are very important. The first one is to add the eloquent models, which are the classes basically we use with MySQL. So after setting up our local database, we need to set up the classes we'll use to access the database and replace the old CRM repository with the new classes we have in place. Then we need to go in the controllers and change all dependencies from the CRM class to the eloquent classes, so that we can now use and rely on the local database storage. The third step is to use the local storage instead of the CRM storage to pull all the data for the view. So everywhere where we had access to the old data, now we are going to be using a different approach to pull MySQL data for the same views. We need to switch all variables to the new naming convention. So because the CRM was having one naming convention and we were relying on something else when on the standards basically in Laravel when we were creating our database, we have to switch all of the variables to meet the new details. We need to change the way we access data in the views from arrays to objects. And finally, after doing this for all of the classes, for all controllers, all views and models that we have in the full project, we need to adjust all the unit tests as well, because they were also relying on some previous structure. And when estimating the time to switch from the CRM to a local storage, it turned out around 30 days, because we needed to focus on all of these different segments to be able to achieve that. And that's a lot, because it solved our problems from one side, allowing us to start lean and to not invest a lot of time at the beginning for creating this full infrastructure. But on the other side, it's causing us a lot of time dedicated to switching the storage afterwards, when we basically need to create our own infrastructure for that. The question is, how can we save time by improving the design of the code? So the first step to do that is not to depend on concrete implementations. So what we did before was we relied on one single class that was getting us all of the details from the CRM that we needed. But that class didn't have any rules it adhered to. It was only written simply so that we can get everything we needed. What we did over here is created an interface, a contract for all of the classes that we're going to use for handling our storage. So basically, this is a candidate repository interface. It's using the repository pattern for handling database manipulation. And this interface is outlining all of the methods that we're going to rely on to get candidate details. So it has a method for getting all candidates, their details, adding, updating, deleting candidates. And the same thing would go afterwards for candidate experience, for candidate education, everything else that we would need to get from that CRM, and that would afterwards need to be adjusted to work with the local database. So now if we look at the implementation, what we have in the edit method over here is accessing this repository over here, and then using that to get the candidate by ID. And this is a unified way of accessing the candidate details, because right now we are only depending on something abstract. We're not depending on a concrete implementation, which is a CRM or a local database. We are depending on the contract of what the storage should look like. And that's it. Now the controller doesn't know how things are implemented in the background. It only knows that it has a way to access them and how to use that. The second step is to be mindful about what our program expects. And this is related to the accessing the data mostly. So how are we accessing data in the views, objects or arrays, and how are we, what naming conventions are we using? So we should be very careful about adhering to the same naming conventions in both cases to make our code reusable. So since we are relying on the eloquent models, and in Laravel that's basically the structure of those, so we have a class candidate, which apart from some helper methods over here, it has overview, it has education and experience. So these are related details to the candidate class, written in the same way as they would be if we were using the models. So basically, initially when creating the infrastructure for handling the CRM data, we are thinking about how are we going to handle the same thing afterwards when we switch to a local database. And now having this in mind, we are writing the infrastructure of our classes to provide the same experience, to provide the same details on the same way. So right now we can access the candidate details in the same way that we would if we were using a local storage. These are the things that we focus on here. And this is how it's translated in the view. So right now we can get the candidate experience through the candidate object and then use them in a unified way throughout the whole application. And the third and most important step for all of this to work is to bind the abstractions with concrete implementation. And this is, again, something Laravel specific, but it's also available in other frameworks. So you can look it up if you're not sure how to implement it in the programming language you're using. Basically, what we're doing here is we're binding this candidate repository interface to a concrete implementation, which initially is our Zoho candidate repository. So a repository which uses the CRM as a concrete database storage. So now whenever we call the candidate repository interface throughout our application, the app would be able to translate it in the background to a concrete class, which is the Zoho candidate class, and then use the actual database, the actual storage engine accordingly. And now if we do that diff, as we did before, the only change that we would have in our application is this. So instead of binding the Zoho candidate class, we would need to bind a new repository class, which is our local repository for managing the candidates from our local database. And that's it. Everything else stays the same. And to be able to achieve the new functionality, we should add new classes instead of changing old code. So basically, again, the first step would be to add the Eloquent models to use with MySQL. So apart from creating the database structure for a local database, we would need to create the classes that we're going to use to access it. And this is the same step as we did before. So just adding new code to the code base instead of changing existing one. Then we are adding again a new class, which is MySQL candidate repository, which implements the candidate repository interface. This is the class that is going to handle all of the database manipulation with our MySQL database, following the same contract, the same interface that our CRM repository was following, so that the app, we wouldn't have surprises afterwards when changing the implementation, because we are following the same rules. We're just adding different classes. And finally, that line that we just saw, change the binding for the candidate repository interface from our CRM to our local storage. And the estimated time to switch here was 5 days, which was extremely simpler than before. The caveat is that we were forced to spend much more time up front thinking through the whole logic and making sure that we have everything in place so that we know how to create a structure that can be easily extended afterwards or changed to a new storage. So we invested some extra time at the beginning, but we gained much more when we needed to do the change. And the thing that you should keep in mind here, which is extremely important for the robustness of the code and for making it stable and not easy to introduce bugs and all, is basically the fact that we are adding new code instead of changing existing one. So when you're changing old code all the time, it never gets tested enough, and the system is not stable and not resilient over time. But when you add new code and your old code gets constantly tested with every new extension that you're doing, it's much more stable and much harder to get new bugs in the future on the old tested code. This example is just the same with open source libraries that we're using. So you never change the code, but you're relying on some existing code that somebody wrote, and you keep on testing it until it becomes so stable and used by so many people that it's hard to break, basically. Now, another example on the other side of the spectrum. So again, trying to follow the same example that we did before, we started implementing a feature for integrating GitHub profiles. And this was supposed to help us review everyone, their coding history and their projects and skills. So following the same approach, we wanted to create an environment that could, the code base that could easily be extended with new Git softwares in the future. So basically, we started with GitHub. We wanted to, depending on the candidate, we wanted to integrate GitLab or Bitbucket, so they would get a chance to select their preferred version control system, and then add a link to it so that our software can automatically handle everything in the background. For that purpose, we created this. So we were relying on the factory design pattern, and we created this version control factory, which was initializing a class depending on the type. So basically, the user would set the type of the app they were using, and then based on that, we would instantiate the proper class and pass it along to the program. Again, we had this contract, our interface abstract version control, which was outlining all of the methods that our version control classes should implement. For starters, only GitHub, and afterwards all of the rest. And here is the GitHub class actually implementing the abstract version control. So the GitHub API here is an external package that we're using to handle GitHub integration for us. Another thing to notice is this adapter class, which was basically created to adapt the output that GitHub gives us to serve the purposes of this application. So in the future, this adapter would be used with all other apps that we are going to integrate so that it adapts basically the output that they give to the internal needs of our software. And this is the part of being mindful of what our program expects from the previous example. So we know how we are going to access the variables, and we want to adapt all of the responses based on that. So the actual implementation, over here we're relying on an abstract version control factory, just as we did with the repository before. And what we do is we get the version control type of the given user, and based on that we initialize the proper class using the factory method over here. And after that, so we use that version control object to get the user details and user repositories from the proper engine, whether it's GitHub, GitLab, or Bitbucket, returning the data to the view at the end. The problem here is that even after a while, we never integrated other engines other than GitHub. So we kept on using the same functionality. We never had the actual need to go through all of these additional integrations. We never did that, but we had our code bulky, and we spent a lot of time creating this perfect architecture that a time that we could actually dedicate on something much more valuable. So this is like the example when you can do something manually in 2 minutes, but you spent 2 hours trying to automate it. Exactly what we did here. So spending a lot of time trying to over-engineer, trying to and it's great for a practice project, but not for a project where what you should focus on is basically the time that it saves you and the value that it brings to your customers. So is there a better way to do this? This is actually how we could have done this in just 2 lines of code without using any factories, any design patterns at all. Just using that same package for integrating GitHub API, and then accessing all of the user details and the repositories for that user. So this is a 2-line solution to the same problem, and it saves a lot of time to all of us. In numbers, it's 10 times faster to write it. And if in the future we need to extend it with additional version control systems or Git engines, we could easily do that because this code is so simple that anyone can read it and anyone can extend it. So when you look at the 2 examples, why time-driven development? The first and very important thing is that software design practices come with trade-offs. So we should know them and think about them whenever we choose the right solution for our project. Basically, in the first example, we had to spend a bit more time upfront to create a good architecture that can be easily extended and maintained on the long run. But then we saved a lot of time at the end because we didn't need to rewrite the whole thing just to implement a different storage. On the other side, we have the simpler application where we spent, again, a lot of time trying to create this good architecture and create a design that's easy to extend. And at the end, we realized that we are not going to need it. So basically, think about the trade-offs that come with the solution that you're introducing, and how is it going to help you with your project and with your work. One rule of thumb that you can use every time is that software design principles should simplify your lives, not complicate them. So if you find yourselves using something that it's using some good practice or something that a lot of developers follow, but it's not simplifying your life or the lives of people working with you, then it's not worth it. If it makes things more complicated, you're either not doing it right, or it's not the right solution for the problem. So just think about it, discuss it with the team, and make sure that you're not focused on over-engineering things just for the sake of adhering to some good practices. And a very important thing is to think about the bigger picture, because that would help you actually create value with the software that you provide. So why are you developing the thing that you are developing? How is it going to be used in the future? Should it be extended, or will it stay the same and never be touched again? And based on this, you will be able to plan your time accordingly and make sure that you only dedicate your time to things that should be there in the long run and should be maintained and extended as you go forward. To start practicing it, first, whenever you get a task or a new project, try to understand the business goals before proposing an architecture. If you're working with a team, talk to the manager, talk to the whole team. If you're working alone with a client, try to discuss things with them directly, understand the business goals, and only then propose an architecture. Because oftentimes, especially with startups, it's much easier and better to create a fast MVP and then, based on the user feedback, change everything and adapt. So only then focus on refactoring and creating a better architecture that could easily support the project. But if you focus on creating a great architecture up front and then find that your users are not going to use it as you intended, then you risk having to rewrite the whole thing again and wasting that time that you spent up front on polishing your code and trying to make it better. The second thing is to always have the context in mind when designing software. So the same thing we discussed before, is it going to be a simple one-time project? Is it going to be a long-term thing? Should we extend it at some point, or is it going to keep working as the index.php file of levels? So basically, whatever it is, just keep the context in mind and use that as your guide to design the software and create the right architecture. And finally, this is for all of you, especially that are using Twitter and shaming people for not adhering to best software design practices. Don't do that, because this is not something that just comes out of the box and everyone should blindly follow it. It's something that is very tightly connected to the actual project, to the actual needs of the customer and of the project itself. So it should be carefully thought through and not something that everyone needs to adhere to at all times. And the last thing I want to leave you with before we end this presentation is that software design principles are your tools, they're not your goals. So try to use them as such, try to use them to make your lives easier, try to use them to make it easier for whoever joins your team to manage through your code and understand it easily, but don't strive to achieve them as the end goal, because that's never working out at the end. Thank you.